I, Dr. J. Kishore Babu, the convener of the FDP, hereby invite Dr. J. Sharanya, Associate Professor, Department of Chemistry, to introduce today's speaker. Over to you, madam.
Dear participants, it gives me immense pleasure to introduce today's speaker, Dr. Saranya Azaruddin, who would enlighten us on the topic Coatings Tribology for Protective Applications. Saranya Azaruddin completed her Bachelor of Science in Applied Sciences and Master of Science in Applied Chemistry from India. Currently, she is a scientist at University of Vienna, Austria. She started an industrial PhD position at Accord AS in collaboration with Technical University of Denmark. She received her PhD in 2011. She moved to Austria in May 2012 and started working as a scientist at Austrian Excellence Center for Tribology, Wiener Neustadt, until 2018. She associated with projects related to surface technology and coatings. She also wrote proposals for various national, international, and EU funding calls. Her main research interests are in the field of developing and testing of wear-resistant coatings for various tribological applications. She has published more than 20 international papers in reputed journals. Madam, it is our privilege to have a scientist like you in our midst to enlighten the participants. Even though you are thousands of kilometers away, you readily accepted our invitation for this online FTP, for which we are thankful to you. Over to you, madam, to address the participants.
So hello, can you all hear me now?
Yes, madam. Yes, madam.
Okay, so very good afternoon to everyone. So I just start sharing my screen. So let me check if it will work. Okay. Okay. So can you see my screen now? Hello?
Yes, madam. Yes, madam.
So you can see my screen now?
Yes, madam. We are able to see.
Okay, great. So it's fine. Okay, great. Okay, a very good afternoon to everyone. So first of all, I try to thank my friend Saranya because of her, I'm here today to present before all of you. And she's my very old good friend because we did a master's together in Coimbatore Institute of Technology. And then afterwards, I came to Denmark for doing my PhD. And then currently right now, I'm in Austria. I'm a scientist. Basically, I started as a PhD student in Denmark for pursuing a PhD on surface and coatings technology for non-stick applications. And afterwards, I was working in India in a company in Bangalore for 3 months. And afterwards, I moved to Austria. From 2012, I'm working here in the field of tribology in various projects, especially focused on coatings for protective applications. So I really thank all of you for giving me this wonderful opportunity to present just about tribology and related topics. So I start with the introduction. So I hope many of the people, when I tell to them that I'm working in the field of tribology, so many people doesn't know what is this term tribology. So the term tribology is derived from the Greek term called tribos that indicates detritions or gliding. So anything that has to do with gliding or detritions, it comes in the field of tribology. So whenever I talk to my friends saying I'm working in tribology, so people always ask me, is it something to do with biology or?
Madam, sorry to disturb you, madam. Can I share PPT from my side?
Yeah, sure. Is it a problem now?
Yeah, they are not able to, participants not able to see full page.
Okay, 1 minute, sir. I try. Maybe I'm doing it the wrong way. Now also, no?
Yes, madam, same status.
Okay, so fine. So I will stop sharing. So can you share?
Yes, madam.
Okay, great. Yeah. So I will close this.
Just you say next, madam.
Okay, I have to come back to the participants list, I think now. Okay, I will start share. I will start my video, so I hope you can see me.
Yes, madam. Yes.
So I don't have to do anything, right?
Yes, madam. Just say next.
Okay, good.
Are you able to see PPT, madam?
Yeah, I can. Yeah. Okay, so I will continue with the slide number 1. I mean, the next slide, please. Yeah, so whenever I talk to my friends and just telling about tribology, people always say, okay, what is tribology? Is it something to do with biology or is it something to do with tribes? Because the term tribology sounds very much related to tribes, but it has nothing to do with biology, or maybe it's application oriented in biology, but there's nothing to do with tribes. So main tribology means friction, wear, and lubrication. So anything, a science that deals with friction, wear, and lubrication, then the term is called tribology. So there are many branches in friction and wear and lubrication. You can talk when it comes to lubrication, it can be chemistry, it can be chemical engineering, it can be mechanical engineering in lubrication. When it comes to wear, there are so many fields involved, like mechanical engineering, material science, surface coatings, chemistry, physics, and many more. And also when it comes to friction, there are so many comparisons that we can do in our daily life. What is friction and what is wear? So next slide, please. Yeah. Okay. So what is tribology? Why is it so multidisciplinary? It is a very interdisciplinary field, because if you start with the term tribology, there are so many fields involved in one field. For example, it starts with material science, because material science is a very basic thing for tribology to start to learn the basics. For example, in material science, corrosion prevention is one such topic, coating technology, and tribochemistry, environmental technology, and recycling. These are the terms that counts to material science when it comes to tribology. And when it comes to mechanical engineering, there are so many investigations possible, like damage investigations and testing of lubricants, testing of surfaces, and there are so many calculations involved in mechanical engineering when it comes to tribology. That is contact mechanics. And also tribometry, there's also a field of mechanical engineering contributed only to tribology. And when it comes to technology, there are so many technology involved, like surface technology, constructions technology, and management of the knowledge in tribology. And there are so many application-oriented technologies that is based on chemistry, like lubricant chemistry, lubricant technology, and tribochemistry, tribo-layer formation, etc. So this is really a multidisciplinary field that you can apply your knowledge of tribology in many different fields. So I know friends who are in chemistry working completely on lubricant technology, but they still publish papers in tribology journals. And I know people from mechanical engineering who do a lot of testing related to tribology, and they still publish in mechanical engineering journals. So there are so many interdisciplinarity in tribology, and it's a very, very interesting field. And I'm really happy that I'm in this field. Basically, I'm from chemistry, but still I started doing coating, and then slowly I became a scientist in this field. And in India, I feel tribology is really underappreciated because there are very few companies who focus only on tribology. And this is very difficult to also find a job in tribology. And this is a problem that we have to evolve with this knowledge to bring more such research in India. So next slide, please. Yeah, so tribology is really an everyday phenomena. Yeah, so when you walk, you know, you need good friction, you know, to have the balance. When you don't have the friction, then you will fall. You know, this is very clear. So friction is everywhere when you walk, or for example, in the eye lenses. When you apply eye lenses, a very good lubrication is very important. And this is also a part of tribology. And many researchers are working on biotribology, focusing on improving the comfortness of lenses, because I saw many people who use lens have problems with lubrication because they used to have burning sensation in the eyes. They are not very comfortable. So many research in the world is going on biotribology, focusing on these kind of lenses to increase the lubrication and to increase the comfortness for the people who wanted to use these kind of lenses. And when it comes to sports, for example, when you cycle, when you go for cycling, this is very important that you need a very good grip, you know, between the tires on the road. And this is basically friction. You know, when you don't have a good friction, you will really fall. So this is very important for safety measures, not only when it comes to cycling, but in many other fields like aerospace industry and automobile industry. This is very clear that they need a very good friction in many fields like trains, tracks. I mean, the friction between the wheels of the train and the tracks, this is very important, and they need to have a very good friction to, you know, to have a very good balance. And when it comes to welding also, there are so many factors involved in welding, and this is also clear, focusing on tribology. This is a kind of interrelated tribology. And next slide, please. Yeah, so friction. So basically, what is friction? Yeah, friction is of resistance to motion between two bodies in contact. So whenever there are two bodies in contact, there will be a frictional force that we don't see, you know, that you don't feel sometimes. So it depends on how the surface is and how the other body is. Like, for example, in this picture, you can see that a man is trying to push the furniture, and there is a motion involved in pushing. I mean, there is a force from the man, and there is a motion happening, and there is a force of friction which is always happening in the opposite direction of the force, pushing force. So this is clear that whenever there is a two body interaction, there is always a sliding, or whatever happens, there is always a frictional force involved in it. So for example, when there is a smooth surface, and there you need a very small push, and there is a very low friction. And whenever there is a high friction because of a rough surface, and you can see there is a big push and there is too much force involved where there is high friction. So these are very basic examples that you encounter in daily lives in home. So it is always, as I said, friction always works in the direction opposite to the direction in which the object is moving. And for example, when you try to push a book along the floor, and friction makes this quite difficult. And when there is low friction, you can easily move the really easily move the book. So this is really clear. There are many types of friction, like static friction, when the two bodies are not in motion, when they are really unrest, there is a friction involved, that's called static friction. And dynamic friction, dynamic means the name itself indicates that there is a motion involved between the two bodies, and that's called dynamic. And rolling friction means when two bodies are rolling, there is also some type of friction involved in it, and there you say it as a rolling friction. So basically all the concepts are the same, but it depends on which form the two bodies are in. For example, when there is a fluid to fluid force trying, and there is also a kind of fluid friction. For example, when you try to put the water into, when you try to put your hand into the water, there is a kind of friction that that allows you to go freely, and there is also some kind of force that pushes your hand back. So this is a kind of also a friction involved in the fluid. So these are the kinds of basic kinds of friction that I wanted to just indicate what are the types. And next slide, please. Yeah, so wear, basically what is wear? So wear and friction, they are all interrelated phenomena. So wear is defined as the irreversible material loss of interacting surfaces. So whenever there are two materials involved, and whenever there is a sliding happens, there is a wear. I mean, there is a problem of material loss due to friction or due to any other conditions, like due to low lubrication or due to corrosion. Any wear can happen. And when a wear is happening, there is a material loss. So this is very clear. There are so many wear mechanisms involved, and the physical and chemical processes within these kind of two sliding pair, which leads to any changes in material or in the shape or any chemistry changes. This is all comes under wear mechanisms. For example, if you see this picture, there are two bodies in contact, and there are some asperities. Asperities means there are the form of the surface. And when you see, there are so many possibilities of wear mechanism that can happen. Surface fatigue is one kind of a wear mechanism where there is a fracture happening and the material can be removed. And abrasion is a very common phenomenon. There is a wear happening, and whenever there is a material removal, people or scientists normally think, or they will give so much importance if it happened because of abrasion. Abrasion means stronger, I mean, than the other body, harder than the other body, and the harder body can abrade the other material and can cause grooves or abrasion. And adhesion means like whenever there is a two material contact, there is always a material transfer happens when from the weak material to the harder material. And normally when there is a material transfer from the weak material to the strong material, then the weak material will lose the material and the strong material. So there will be a material gain. I mean, the weight will gain in the stronger material. So this is called adhesion. And tribochemical reactions, there are so many forms of tribochemical reactions possible. Particles involved in the reaction that can bring tribochemical reactions. And there are some lubricants when they are used in such kind of abrasion, and this can create some tribochemical reactions. So these are the four different types of wears that is normally occurring in any kind of sliding between two surfaces. Let's change next slide. Yeah, so to describe more about wear mechanisms, like in this picture, it's more clear. Adhesion wear happens, like one material is transferred, and how the abrasion wear is transferred. In the second picture, you can see that the material is fractured and removed from the surface because of the hard wear. It is like a kind of fracture happening just because the other material is hard, and the material is removed from the surface. And corrosion wear is a kind of the material is corroded, and because of corrosion, the material flakes can be removed from the surface. This is called corrosion wear. And the fatigue wear, the wear mode is like, if it is abrasive, I mean, there is asperities cut from the surface. And if it is adhesive, and the asperity is cold weld. And surface fatigue means cracks from rolling or impact. And corrosion means there is a sliding impact. And fatigue wear, fatigue wear, there is a possibility of cyclic loading which can happen, that can remove the material, form of fatigue wear. And there is also a form of normal cycling load, where the normal cycling load can also result in fatigue wear. Yeah, So these are the forms of very basic forms of wear modes or mechanisms. So next slide, please. So what is the interrelation between friction, wear, and lubrication? This is like clear. Whenever there are two surfaces, there can be an increased friction between the two surfaces that can cause wear, or there can be an excessive heat formation. So these are the two possibilities whenever there is an increase in friction. So wear, what are the forms of wear? We have already seen, like adhesive, abrasive, fatigue, or corrosive wear. And what will happen when there is an increased friction? That can cause a lot of problems, like loss of viscosity in the lubrication, and so you need to use more lubrication to achieve the same performance, to increase the, to decrease the friction and to decrease the wear. Or maybe you have to there is an increase in additive depletion, or there is an increase in oil oxidation, or the increase in varnish potential. So these are the problems that can happen when there is an excessive heat formation because of the lubrication used. These are the interrelation. Whenever there is an increased friction, there can be an increased wear, and it can also form excessive heat. So the interrelation between friction, wear, and lubrication is very important to know what is happening on the surface and what has to be improved to improve the lifetime of the surface. So next slide, please. So what are lubricants? Generally, we are using lubricants in many applications in daily field. Like, for example, even in cooking, we are using oil, right? This is generally to reduce the friction and to improve the properties between the food and the surface. Same way, we are using lubricants to reduce friction and wear between two surfaces. When it comes to automobile application, we are well known that we are using a lot of lubricants. And what does a lubricant do when it is in an automobile or whatever? A lubricant main function is to control friction, generally to reduce the heat generation, and generally to reduce the energy consumption. And also it controls wear. As I said in the last slide, it reduces mechanical and corrosive wear. And also it controls the corrosion, like it protects surfaces from corrosive substances. And it controls temperature. Whenever there is a rise in temperature because of friction or wear problems, then it absorbs and transfers the heat, which is a very good property of a lubricant. And what it will do with the contaminants? Normally, it controls the contaminant level in the automobile usage or in any surface that you use, and it tries to transport the particle and other contaminants to the filter so that it reduces the contaminant level in the lubrication. And it sorry, there was a problem. And transport particles and as I said, and it also used to transmit the power, like in hydraulics, it transmits the force and the motion. So when you see a picture of an automobile part filled with lubrication, an oil lubrication. Can you change the next slide, please? So anybody, I don't know if you have heard of the Stribeck curve. Stribeck curve is a basic for any tribologist to work on any problem. Yeah, Stribeck curve is named after a person called Richard Stribeck. He's a very well-known German mechanical engineer. He first described the concept in 1902. And this graph showcases how the generation of lubricant films are critical in the reduction of friction and wear of machine parts. So there are three types of friction generally. I can't see. Okay, one is called boundary lubrication, and mixed film lubrication, and hydrodynamic lubrication. So what will happen in boundary lubrication? In boundary lubrication, two surfaces, when they are together, there is a good contact between two surfaces. So the lubrication is happening in the boundary level, you know, and sometimes in this case, the wear is too much. So they have to control the wear by kind of additives, you know, to reduce the wear. And mixed film lubrication, you know, there are some parts which are touching and there are some parts which is separated by the lubrication. And in that case, it's called mixed film lubrication, you know. And normally in such cases, wear is controlled by viscosity or boundary lubrication film, you know, that is the way it controls the friction and wear. And when it comes to hydrodynamic lubrication, there is too much fluid between the two surfaces, and really the two surfaces are not in contact to each other. And in this case, there is a very good friction between the two surfaces. And most of the time, the wear is controlled by the viscous separation between the two surfaces using the fluid. And when you see, in case of boundary lubrication in the second picture, we always talk about friction coefficient when it comes to friction. This is a very basic parameter to calculate how much load is placed on the surface and how much friction is happening in the surface between the two bodies. And in that case, all this load is supported at the aspirative contact when it comes to boundary lubrication, and that's why we have so much wear happening. And when it comes to mixed lubrication, and this is a kind of again, as I said before, it is controlled by little bit aspirative contract and little bit of fluid between them. And when it comes to hydrodynamic, all the load are supported by the fluid film pressure. I mean, the fluid film between the two surfaces will take all the load happening on the surface. So this is very clear in hydrodynamic lubrication. So these are the three forms of lubrication that any tribologist should work on whenever there is a new problem comes. So people, whenever there is a problem in a mechanical part or in anything related to tribology, then the first question comes to mind is it operating under boundary lubrication, or is it operating under mixed lubrication or hydrodynamic lubrication? And from there, we start really to check what is the problem and how to rectify it. So this is how we tribologists try to see what problem and how to rectify it. So can you please change to the next slide? Yeah, so these are the common test rigs that we use, test apparatus we use in our field of tribology. And to start with, I will show the last machine that's called pin on disc. So in any tribology lab, if you go, a pin on disc machine. It is a very, very basic machine to study any kind of tribological behavior. So the pin on disc, there is a pin holding on the disc, and the disc is rotating and the pin is on touch with the disc. So the pin can be steel material, or it can be a different material, and the disc can be coated, or the pin can be coated. Or in the third case, both materials can be coated and they can be tested. So this is a very basic test whenever there is this kind of tribology test. And the first picture, it's called FZG test rig. And in this test rig, you can see there are two types of gears that is tested in FZG test rig. And normally here, you always test two gears. And this is a normal test that is normally in automobile industry to test the failure of gears and the lifetime of gears. And Timken apparatus, the second one, this is like a block and a ring. A ring will be rotating on the block, and the ring can be coated or the block can be coated, or in third case, both the ring and the block can be coated to see the coating and coating adhesion, or to see the steel and the coating adhesion. So there are some hands. Should I stop for questions or at the last? Yeah, previous slide, yeah. So,
please carry on, madam, carry on.
Okay, yeah. So there is also kind of Alman Wieland apparatus, which is very used rarely to test some kind of specimens for frictional properties. And twin disc machine is also quite common because there's a kind of two cylinders rolling, and to see how the rolling friction happening between two surfaces and where is happening between these two surfaces. And frictional wear test rig, this is also like a cylinder on a ring. The ring is rotating and the cylinder is moving on the ring. And you can still, again, the same way, you can coat the ring, or you can coat the cylinder, or you can coat the cylinder and you can still keep the ring as a steel specimen. And you can see how the coating and the steel is reacting in such surfaces. And mostly, Phalanx apparatus is also used in some very typical mechanical labs. And four-ball tester is a very famous testing apparatus as well, to have 4 balls to see how the rolling friction, fatigue possibilities, any abrasive wear or adhesive wear happening. So this is a very good form of testing all these possibilities in one test. And there is something called lubrimeter, which is not really used. So in this whole pictures, you can see pin-on disc is the main apparatus that is used almost in every tribological lab. And can you please change next slide? Yeah. So what are the lubricant types? So there are basically you can categorize the lubricants into different ways just based on how the form is. Yeah. So liquid lubricants, when the name says that it is liquid, yeah, it can be a mineral oil, or it can be a natural oil, or it can be a synthetic oil, or it can be an emulsion. And when it comes to solid lubricant, this is also clear that it is a solid form of a lubricant. So it can be a powder, or it can be a coating on a surface, or it can be a composite like graphite or PTFE coating, or a molybdenum disulfide. I will talk more about solid lubricants at the end of the presentation, so I can explain more in there. And gaseous lubricants is it is a gaseous lubricant, it's in gaseous form. And when it comes to semi-solid lubricants, generally greases are called semi-solid because it's not liquid, it's not solid, it's a semi-solid. And also soap emulsified with mineral or vegetable oil, it's also called semi-solid lubricant. And all these lubricants are chosen based on the application, like what you wanted to use and where you wanted to use. So depending on the application, you can choose which form of lubricant you wanted to use. And next slide. Yeah. So additives. So what does an additive do normally? As you see, we always use additives in our automobile for our bikes and cars and everything. So what does an additive do? And this is really to enhance an existing property of an already existing lubricant property, or to add a new property to the lubricant, like to reduce the wear, to reduce the friction, or to improve the lubricity, or to decrease the viscosity, whatever, and to suppress any undesirable property. When it comes to undesirable, that means wear, friction, that's called undesirable. And when it comes to automobile application normally. And so these are the main types of additives that we use normally, and that's called anti-wear additives. What does an anti-wear additive do? Anti-wear additives are mainly used when you wanted to reduce the wear by the growth of a protective layer on the surfaces. For example, a zinc dialkyl thiophosphate is a very good example, and this is simply called as ZDDP, and this is very well studied in the field of tribology and in lubrication. They use ZDDP almost in most of the studies when it comes to a study related to an anti-wear additive. And when it comes to extreme pressure additives, they protect the components from seizure by the formation of the coating on the surfaces, like graphite or molybdenum disulfide is a very good form of extreme pressure additive that is normally used. And when it comes to viscosity index improvers, they use to prevent or minimize the viscosity index of lubricants, especially at high temperatures. Whenever there is an increase in temperature, there is always a possibility of change in viscosity. Like increase in viscosity normally happens at very high temperatures. In that cases, you really have to decrease the viscosity or increase the viscosity using viscosity index improvers. And when it comes to friction modifiers, generally these friction modifiers are used to control friction and typically made of solid particles like generally graphite or molybdenum disulfide or tungsten disulfide, or used as friction modifiers. And what does a corrosion inhibitor do? It protects the surfaces normally. Whenever there is a chemical active substances such as oxygen, to create a corrosion resistant layer, to decrease the corrosion layer or to improve a corrosion resistant layer, then these kind of corrosion inhibitors are formed. So next slide. Video. So, okay. What kind of additives are normally used when it comes to engine oils? Or ATF means auto transmission fluids, and general or oils and hydraulic oils, or industrial gear oils or automotive gear oils or greases. So what kind of additives are normally used in this kind of engine oils? So when it comes to detergents, these kind of additives are normally used in engine oils or ATFs, that is auto transmission fluids. And dispersants are normally used in engine oils and ATFs, and antioxidants are also used normally in all types of oils. And rust inhibitors are also used in all types of oils, and antiwear is used in kind of engine oil or ATFs or hydraulic oils, automotive gear oils, industrial gear oils or greases. And extreme pressure additives agents are also used sometimes in industrial gear oils, in automotive gear oils, and greases whenever there is an extreme pressure happening. And viscosity improvers is normally also used in engine oils and ATFs, and sometimes in industrial gear oils and sometimes in automotive gear oils. And pour point depressants are also used in almost most kind of them, except grease. And antifoam additives and dyes, friction modifiers is also used typically in engine oils, ATFs, and other kinds of oils. So this is a kind of table to see what kind of additives are normally used in different kinds of oils that we use in daily life, in automotive or other applications. So next slide, please. Yeah, so I'm not a very good expert in these kind of additive chemistry. So I'm just giving an overview of what kind of examples or we have in antiwear agents. For example, mainly antiwear agents are used because they will have a very low activation temperature. To activate these antiwear agents, you really need a very low temperature. So in that cases, antiwear agents are used, and also it can create a durable layer, and it can shear easily under boundary lubrication conditions. So that's the main usage of antiwear agents. And there are so many antiwear agents possible. And some examples are organic polysulfides, dithiophosphates, and dithiocarbamates, and zinc dialkyl dithiophosphates, like as I said before, ZZTTP. And when you see the picture here, the down picture, you can see that the ZTTP has formed a kind of a layer which is in micron thickness on a bearing surface. And it can also form iron sulfide, zinc sulfide, and it can also form zinc polyphosphate layers of very thin layers like nanometer scale and micron scale. And these kind of layers are very important in some kind of applications. And in some cases like ZTTP, they replenish these kind of layers, which will improve the lubrication for a long time. So that is the main point of using antiwear agents in such applications. So can you change next slide, please? Yeah. So extreme pressure additives. So mostly extreme pressure additives are used when you need anti-seize property or anti-scuffing property. And generally EP additives, normally they need very high activation temperatures compared to antiwear agents. And they have a very extremely durable protective films formation. And it's also thermochemically formed layers. It is extremely durable in case of EP additives. And normally the examples are iron phosphide, sulfide, sulfates, oxides, and carbides. These are main examples that we normally use when it comes to EP additives. And extreme temperature and mechanical pressures to avoid micro welding and to avoid scoring or seizing in the materials used. And also compounds based on phosphorus, sulfur, sulfur phosphate, calcium sulfate, sulfur carriers are normally used as extreme pressure additives. And when you see the mechanism of sulfur carriers and extreme pressure conditions, you can see there is a form of physical adsorption can happen, or chemisorption, or any sulfur pressure conditions. It can form these kind of reactions to have this lubrication properties in hold. Can you change next slide? Yeah. Friction modifiers, so they are really a very mild anti-wear additive or EP additive. And they are also called anti-transmission fluid that contain so-called anti-quack additives. They are normally called friction modifiers. And they have a very durable low resistant films because of adsorption mechanism that is happening because of using friction modifiers in the oil. And mechanically working solid lubrication compounds like MOS2, PTFE is also a form of friction modifier. And how they are classified, you know, the classification is mainly based on how they form these kind of layers. And for generally adsorption layer, when it is forming, they form always with long chain carboxylic acid, for example. And they also form tribochemical reaction layers with phosphoric acid and thiophosphoric acid esters, sulfurized fatty acids, and also friction polymer forming as also can form. And sulfurized olefins and glycol triglyceric acid partial esters is also a kind of example. And also organic metallic compounds forming is a form of formation of friction modifier. And molybdenum dithiophosphate is a kind of friction modifier too. And as you see in the picture, the flow of friction modifiers is between the metal surfaces to improve the lubrication properties. So can you please change next slide? Yeah, foam inhibitors, they're also a kind of additives. Normally they are used to enhance the oxidation and cavitation properties. Whenever there is an insufficient oil transportation, these kind of foam inhibitors are used. And mechanism is mainly to attach and separate the bubbles and coalesce into a bigger bubble and rise to the surface, and easily carried out of the lubricant due to the insolubility and their strong affinity to polar metal surfaces. And the foaming tendency is influenced by many different factors, especially surface tension, which is a very important factor for foam formation. And surface active substances like detergents, corrosion inhibitors, and other ionic compounds are very much influenced by the surface activity. And the surface foam and inner foam is also like physically dissolved up to 9% in mineral oil. So these are the factors that normally influence the foaming inhibitors. And linear and cyclic polydimethyl siloxanes is a typical form of foam inhibitor. So I don't want to go detail into this topic because this is not my my expertise. So there's some examples I really wanted to give. And can you please change to next slide? So yeah. So as many of people know, there are many methods. These are the table that I got from my chemistry department, how they test when it comes to a lubricant analysis. There are different lubricant analysis possible. And total base number is a form of calculating a base number for a lubricant, and it's also called neutralization number. And this is basically for acid base measurement. And whenever there is the total base number is higher, and it's better to neutralize contaminants such as combustion byproducts and acid materials. So they always test this kind of TB. And viscosity is a very important parameter whenever it comes to a lubricant, and Stribeck viscometer is one kind of viscometer that calculates the viscosity. And higher the viscosity index, better the lubricant. So whenever the lubricant performs good, they always check is the viscosity index is higher, or is it better because of a minimum change in viscosity whenever there is a temperature rise. And ICP is an inductively coupled plasma method, is a very common method used for lubricant analysis, and it is a very famous for analyzing the elements in the additive substances via particles and contaminants if there are any in the lubricant. And FTIR is also one form of a very famous analysis method used in almost all forms of chemistry. Fourier transformation infrared spectroscopy, which is a form of identifying lubricants and their components a qualitative and quantitative analysis of lubricant conditions. And gas chromatography, LC, GC, liquid chromatography is very famous also in many chemistry labs. You can see this. And this is a form of identification and quantification of additive compounds, knowing the amount of which compounds is in a given sample. So the normal lubricant analysis methods that they follow whenever there is a new lubricant coming or a used lubricant, to check what is the property that is changed in the new lubricant and the used lubricant, to see really what is the problem with these kind of analysis methods. Can you please change next slide? Yeah, so I'm not sure if many people have known this. Volkswagen is a very big company in Germany, and they made a scandal with the diesel emissions. It was a very big news at the time. It was in 2016 or 2017, I think. 500,000 diesel Volkswagen models have been cited for emission violations. So normally in Europe and in US, they normally test the vehicles for a limited emission level. Yeah, so there are prescribed emission level for each vehicle, and if it goes above this emission level, they won't get the permission to release the vehicle into the market. This is normal process when it comes to releasing a vehicle in Europe or in USA. And they tried to violate some laws in Volkswagen. How did they do is that they tried to install a software which was like sensing a unit parameters of the emission drive cycle, which was set by the Environmental Protection Agency. So what they did is that they tried to install a software in the vehicles that during the testing phase by the Environmental Protection Agency, it shows less emission. But when the vehicle drives on the road, it gives high emission. So this was a big problem that they found out because of a scientist in USA. And because of that, they found out that they had a very high nitrogen oxide emissions, which can increase the lung cancer up to 40 times higher than the federal limits, you know. This was a very big problem they found out, and Volkswagen have to pay really high amount as a fine. It was around $2.5 billion to the US government. And they also wanted to pay money to all the cars which was purchased after 2015. And they have to pay in the money, or between $12,000 and $44,000. Whenever they have to come back to the Volkswagen, they have to pay to each person who bought cars from them. And this was a big scandal. And after that scandal, it was really important that you are really clear that what is really emitting from the lubricant that you're using in the automobile industry. So after that, it was very strict in Environmental Protection Agency that they increased the standards really very highly in Europe. And this is a very good example to see how important to test these kind of lubricants and additives, whatever they put into the oil to improve the properties. So this is the good examples I just wanted to show. So can you please change to next slide? Yeah. So normally, when there is a lubricant transport in a surface, for example, the lubricant flow or the lubricant will have a higher contact angle when it is contacting immediately. For example, in 0 seconds, it is seen that the diameter was 11.25 millimeter, and after 3.6 seconds, it increased to 15.07 millimeter. And after 7.2 seconds, it was 27.88 millimeter. It is clear that with increasing temperature, the viscosity is different in the oil, and the lubricant flow is also different. So mainly to understand the lubricant transportation in the surface, this is very clear that the tribological parameters have to be understood so that a very good lubricant transportation is formed between the surfaces when it comes to automobile or other applications. So if you see the infrared image, this is an infrared image of a bearing surface showing how the oil is working in the bearing, and with different forms of temperature measurement, because there are some places where the temperature is really high and there are some places where the temperature is really low. So these kind of studies are normally happening in tribology. So this is a kind of example I have to show, like how lubricant studies are related to tribology field. So can you please change next slide? So these are the basic things I covered, like a friction, what is wear, and what are the forms of wear and lubrication. And generally, if you see in the whole concept, you can see that the tribology can be applied in many fields, like energy industry. For example, wind turbines, they need the blades to have a very good wear life. That is like for 50 years or so. They really have to have a very good lifetime. In that case, tribology is used in energy industry. And that is a very big company, a Danish company, which is called Vestas, and they invest billions of dollars in research only related to energy tribology to improve the lubrication and to improve the wear properties of the blades, so that they don't want to replace the blades once in a year, because it's too expensive to change the blades once in a year or to protect these kind of surfaces. So they're really trying to apply tribology in these kind of industries. So that's an example of energy industry. When it comes to aerospace industry, in aerospace industry, there are also many forms of tribological studies happening. And I am working in a department where we are dealing with aerospace industry applications, mainly to study the tribology in helicopter gears. Helicopter gears, why is it so important to study tribology in gears related to in helicopters? Because there are many helicopter accidents happening because of this problem, because of low oil. The wear can happen like in a destructive way, that the whole engine can become a failure in seconds, which will take so many lives. For example, there was an accident in Canada in a military helicopter, which happened exactly the same way. The oil was low, the wear was very extreme, and it killed around 8 military people in a second. And it also happened in Russia, where it also killed around 12 military personnel in the helicopter. So in army research, this is very important to improve the properties of these kind of gears so that the lives can be saved. In turbine industry is also very popular, these kind of tribological aspects. And smart surfaces, nano actuators, and biomedical industry is also very famous. And I will come to that later, what kind of applications. And cutting tool industry is also explained detailed. And real-time monitoring is an application of a lubricant tribology, where the lubricants are monitored in a real time. Whenever there is a new particle coming in, they have to see there is a contaminant which hinders the performance of the automobile. So immediately they have to know if there is a new foreign material in the lubricant. So this is called real-time monitoring. So please, can you change the next slide? Yeah. So as I said, how important is tribology in machine elements? As I told you, many examples like in aerospace industry and in automobile industry. In machinery, for example, bearing, gear drive, it's really important to understand what is happening with the related to tribology there. And production, machining, and in tool industry, it's very important to see how the tools are manufactured without any defects in the tools. And transportation industry, for example, as I told, the friction between tire and road is very important. In medical technology, for example, in hip joints, in biomedical industry, tribology is very important to know how the lubrication function between the hip joints work, the lifetime of these joints. I will talk to also give more examples later. And operational parameters are also very important in all these applications. So what are the main operational parameters? So whenever we start a tribological test, we will say what kind of load we need to apply in this kind of application, and what kind of motion we need. So we are applying a load on a surface, and how much load that we have to determine based on the application. And we also wanted to know what type of motion. Is it reciprocating motion or a sliding motion like this, or a rotating motion, or a rolling motion? So whenever there is a different kind of motion happening, there is a different type of tribological parameters involved, or a different type of wear is happening. So we really have to know in a real application what kind of motion is there. Is it a rolling motion or a sliding motion is there? So we really have to know what kind of motion we have. So this is very important for a tribological study in a machine element. And velocity, that's clear. It's very important to know how fast is it moving or is it slowly moving. Temperature, because it's a form of environment, which is very clear. It's very important to know what kind of temperature it's operating on. Duration, like is it 1 second or 5 minutes or 10 minutes, or is it for like 100 hours or 2000 hours? This is very clear. We have to know that. And so whenever there is a structure, if you see the tribal element, there are two tribal elements as you see in the picture, in the center picture, and there's an interfacial element and then ambient medium. So these are the structure of a tribological element. Like two tribological elements are there, and there is a lubricant medium and there is an ambient medium, which determines the whole tribological system. Is it good or bad? When it comes to function, this is very important to see how the surfaces interact in relative motion. Is there is any form of addition happening between the surface, or is the surface too rough that it's wearing really badly, or is there a form of corrosion happening between these surfaces? This is also very important to know. And these are the main elements. Why is it so important? You can say, okay, I don't care about tribology. I just use oil in my car. Then why should I care about tribology? It is really important to care about tribology. Why? Because tribology is particularly important in today's world, because we are losing so much energy in many mechanical components in cars by using too much changing tires often because of wear happening in the tires, and too much oil usage. This is all happening because of energy losses. And why energy loss is very important? Because you're spending so much money on taking this energy loss from these components. And it was estimated in UK that around 2 to 7% of the gross national product results from friction and wear in every industrialized country. I mean, India is an industrialized country. USA is an industrialized country. So every country, it's very important to understand how we can save the energy by improving the tribological properties. And to use less energy, we need to minimize the amount that is wasted, whatever it is. Is it oil, or is it too much wear, too much friction? We have to reduce this. So this is clear why it is important. Can you change the next slide? Yeah, so role of, as I said, role of tribology in energy efficiency. As you see the pictures in, if you see a car, a race car, or a race bike, and kind of a roller bearing, a ball bearing, or a normal gears, or a tire on a road when it is raining or when it is snowing, everything is important when it comes to tribology and energy efficiency. And by doing this, we can save a lot of money when it comes to energy efficiency. And also we can improve the environment by reducing these kind of losses using tribology. And it can be conserved, that all the energy and raw material resources can be conserved for our future generation, and environmental damage can be avoided, and occupational safety and production can also be improved. Because many accidents are happening in the tool industry, even now, many accidents are happening, which can be improved by knowing really what is happening between these two surfaces. Is it a frictional problem, or is it too much heat dissipation, or is it really a normal tribological problem? So these are the things that we have to really know why tribology is very important in energy efficiency. So can you change next slide? Okay, so this is more related to my topic, materials tribology. So what kind of materials we use in every day? We use a lot of metals and alloys. We use ceramics. We use a lot of composites in airplane industry, and we do use a lot of polymers and plastics. And in countries like Europe and in USA, we use lots and lots of wood for construction and for many other purposes. And different engineering parts are subjected to tribological loading, as I said. at different loads, different speeds, different temperature, different environments. Because in India, in South India, it's very warm, but in North India, it's really cold. And also in Europe and USA, it's really cold some places. So you really have to know how the system performs in a warm environment and how the system performs in a hot environment, so, in a cold environment. So this is really important. And the study of materials in different environment when it is subjected to frictional and wear is materials tribology. And why is it so important? Because we have to select the materials based on the engineering requirements. Like, for example, in some applications, you have to reduce the weight, where composites are of very much interest, like in aerospace industry, like in planes. And in some cases, metals are important. Like, why? Because metals are, especially steel, stainless steel is very important for corrosion protection. So metals are very important when it comes to materials tribology. I mean, metals are the basics, because you do a lot of testing with metals, especially steel and aluminum. So they are the basics of materials tribology. And you can choose a lot of coatings based on many different possibilities that you can make the coating. So this is my field, that this is talking on relating more about tribology to materials, like why we use surface coatings in tribology. So can you please do the next slide? Yeah, so I said failure modes, like when it comes to tool failure modes, or is it a surface failure modes? These are the main kinds of failure modes that can happen in addition to wear, like a different kind of material failure modes. So wear, that's clear. If you see the picture, what kind of wear? Yeah, because the material is removed from the surface, that's a wear. So there is an edge removal from the material. And what will happen in the tool? What will increase? The hardness will increase, the ductility will increase, and what will decrease? The friction coefficient will decrease because the material has been removed a little bit. And the next form of failure, a main form of failure, is plastic deformation. And why plastic deformation happens? Plastic deformation can happen by a very high contact pressure, and which can exceed the compression tool yield stress of the tool material, which can compress the material and really permanently damage the material. As you see in the second picture, it's a plastic deformation. Then you really cannot change it because the material is deformed. It's not elastic deformation. The material won't come back to its normal state. It's a plastic deformation. The material is really, really deformed completely, that it cannot come back to its original state. And what will happen? The hardness will increase, the yield stress can increase, and the local die pressure can decrease. So these are the normal problems when it comes to a tool failure. And chipping is also a kind of chipping of the material. I mean, the materials are removed in chips, like as you see in the third picture. And what will increase here? The toughness, ductility can increase. The sharp corners can be decreased because the material is chipped from the corners, which is forming a blunt corner, you know, on the sides. And cracking, this is clear. Cracking is caused by stresses exceeding the fracture toughness of the tool steel. So any material can crack. Even a glass can crack, and any material can crack. And because of cracking, the fracture toughness can increase, and the hardness can decrease. The sharp corners can also decrease in cracking. And galling is a very a form of a damage caused by sliding of two solids. It can be a plastic flow, or it can be a material transfer, or it can be both. We can call as galling. It's a special form of a tribological wear. And the surface corners can increase, and the friction coefficient can decrease in this case. So these are the main forms of tool failures when it comes to tool industry. Because why tool industry? Because tool industry is the main form of industry that uses and studies a lot of these kind of tribological mechanisms in their tools. So tool industry is a very good form of studying these kind of damages. So that's why we are really concentrating on the tool failure modes. And can you change next slide? Okay, what are the factors affecting tool life? So there are 4 different factors. As I said before, the contact pressure, the surface quality is a very, very big factor, and tool quality, tool coating which is a very important factor. Lubrication, this is clear from my previous slides. And why contact pressure? Because the contact pressure decides how the two surfaces are in contact. When there is a very high contact pressure, the two surfaces are very compressed each other. So in that case, the tool failure will increase dramatically. When there is a low contact pressure, then there's not too much pressure, and maybe the tool life is improved. And surface quality, surface of the tool is much smoother than the surface of the sheet sometimes. In that case, the surface quality is very important. If it is a rough surface or a smooth surface, or is it having lots of defects in the surface where the materials can go and hide in the surface. In that cases, surface quality is very important. And tool coating, why tool coating is very important? Because whenever a tool is coated, for example, with a molybdenum disulfide or a zirconium coating or a chromium nitride coating, it has a low coefficient of friction, so it can be easily reduce galling and the tool wear. Lubrication, again, it performs better when it comes to performing the tool life, to increase the to decrease the wear and to decrease the friction. Thank you. And can you change please to next slide? Yeah, coating. Yeah. So this is like, what is coating? Coating is generally a covering that is applied to the surface of an object. So it can be of any purpose. For example, it can be decorative purpose. For example, in the flower washes, sometimes there is a coating just to improve the look of the flower wash. And it can be also to protect the surface. For example, in the car windows, you can see there is a black coating that nobody can see inside the car. So this is a kind of protective coating. And generally engine parts are coated, turbine blades are coated, cutting tools are coated to improve their performance. And coating method, they are generally wet coating method and dry coating method. They're the two different coating methods. So you can see the coated tools, for example, as you see in the picture, like the gold color or the titanium coated, which is gray color. Can you please change next slide? Yeah, wet and dry coating example. So spray coating is a very typical wet coating method because it's very cheap, because you just have to apply a surface and you have to apply by spraying. You have the material inside. It can be a powder. You can have a powder spray, or it can be a powder in a liquid, so you can have a wet spray. So this is a clear spray coating. And spray coating can make thin coating or a thick coating, depending on how many layers you want. You can have to dry the coating and then you have to apply one more spray coating. So this is a form of increasing the thickness in the surface. And PVD physical vapor deposition is a typical dry coating method, but it is extremely an expensive technique that many people doesn't want to use it because it's extremely expensive. And even for small parts to coat, this is very, very complicated. So very few companies are very professional in making these kind of PVD coatings. And in that cases, they're really, if it is needed, then they go for PVD coating because it's very expensive compared to wet coating like spray coating, or there is also something like dip coating where the material will be there and the substrate will be dipped into the coating. So the coating will be on the surface. So this is a kind of dip coating. This is also a form of wet coating. Can you please change next slide? Yeah. So why we are doing surface treatment? Why we are doing coatings? Because generally to increase the tool life or to reduce the friction in any kind of surface. And what are the types of surface treatment? Generally, there are so many forms of surface treatment. I don't want to go into detail because it's really a big topic. So I just put some examples like heat treatments. Generally, they are really good to improve the hardness of the material. And nitriding is a very good example, followed in many industries, especially in steel industries. And hot comb plating is a very famous form of electro deposition. And when it comes to dry method, as I said, it's PVD, physical vapor deposition, chemical vapor deposition, and thermal diffusion. They're all the expensive form of dry methods to coat the surfaces. And what kind of common coating materials we use in PVD and CVD? Generally, nitrates and carbides. They are the best form that you can see in PVD and CVD coated substrates, like titanium nitride, chromium nitride, titanium carbide, or tungsten carbide, I was working in my PhD mostly on chromium nitrate and titanium nitrate coatings for non-stick applications. They are very good in forming very thin coating, and they have a very good resistant layer, wear coating layer, and this is very clear why it is used in many applications. And solid lubricant films such as DLC and MOS2 is also very popular. And CVD, why CVD is different from PVD? Because CVD requires very higher temperatures than the physical vapor deposition, and the high temperatures can really soften the dye, which then again needs a rehardening process. So it can also cause some dimensional distortion. So there's a difference between CVD and PVD, a basic difference. And many PVD and CVD coatings are mostly brittle sometimes because it's very thin, and it's very hard to make a hard coating with PVD and CVD. So normally they improve the hardness of the coatings by a layer, first layer on the surface, and a second layer is the coated surface. So they always have a adhesion layer on the surface to improve the adhesion and to improve the wear. And duplex coating, as I said, it is called duplex coating because they have a nitriding layer and then the coating layer. So it's like layers of coatings, which improves the lifetime because one layer will wear off first and the second layer will wear off, the third layer will wear off. So always there is a lifetime improvement for these coatings. So can you change the next slide? So I just wanted to have like application parts, like why these tools are coated, because this is a kind of a hot coating tribology. If you see, these are the examples that I want to show. The blades, the tools, I mean the drillers, the drilling tools normally are coated so that they can improve the lifetime of these kind of coatings. So can you please change the next slide? So this is basically my paper because I was working on manganese phosphate coatings. In these coatings, we were checking the wear of the surface after using in a SEM, scanning electron microscopy. You can see there are lots and lots of different forms of wear in single surface. If you see, there are form of cracking. In the first picture, if you see, there are a lot of wear debris. Wear debris means that the wastage from the cracking of the materials. And in the second picture, if you see, there is a lot of oxide film formation. And in the third picture, you can see there is a lot of ploughing. Ploughing means it's like ploughing the field, that the material is removed like a plow from the field. And oxide debris is also, as you see from the second picture, it's a kind of debris formed from the oxide film. And in the fourth picture, you can see the fracture. I mean, the coating has been fractured, and there is also flattening of the grains because the grains are there and there is a surface going on the surface and the surface has been flattened. And plastic deformation can be clearly seen in the fifth picture, that the material is deformed a little bit. And the sixth picture is a zoom in picture of the plastic deformed layer. You can really see how the surface has been deformed. That will not come back to its original form. So this is a show from my paper to see how you can check for different forms of wear in a SEM, I mean scanning electron microscopy. So can you change next slide, please? So surface texturing. So what is surface texturing? Surface coating is a form of protection of the surface, and surface texturing is another form of mainly they use laser or machine hammering or etching to create some form of surface, some kind of dimples. For example, in the first picture, you can see the dimples. Dimples means like round holes kind of thing. So whenever there is a wear happening, all the materials from the wear will be deposited into the dimple. So the wear life of the whole surface is improved. So this is a very clear form of surface texturing to improve the life of the surface. And in the second picture, you can see there are kind of lotus surface. We call it as a lotus surface because in lotus, you can see whenever there is a water on the surface, you can see there is a high contact angle, that the water doesn't touch the surface. So this is called lotus surface, and lotus mimicking surfaces are very popular in tribology and hydrophobic surfaces to create hydrophobic surfaces. And texture like a line surface, if you see in the second picture, and to create small patterns so that there is it's not so much properties. So they are the ones. So these are some examples of surface texturing. Can you please change the next slide? Okay, solid lubricants. As I said, solid lubricant is a form of a coating. But why we have solid lubricant? Because we have a bulk material, we have a thin film, and we have a surface. So always we need to have a low and steady friction. We have to improve the wear resistance. It has to be a adhesive layer. It has to be a corrosion resistant layer. It has to be non-toxic and economical. So this is why you're using solid lubricants. So can you please change next slide? Sorry, there was some problem. Okay. Sorry, I can't see my present slide.
Hello, I changed, madam.
Sorry, I can't go in because there was some problem in my internet. Go in. Oh. Yeah, now I can see. So why solid lubricants? Why is it very different from the liquid lubricants? Because they have negligible, I mean, no vapor pressure compared to liquid lubricants. And they have wide operating temperatures like minus 273 degrees Celsius to 250 degrees Celsius. And that's why it's used mostly in space applications. And no surface migration, and it is electrically conductive. And friction is really independent of the speed. And that's why it's very popular. And a poor thermal conductance, but liquid lubricants has a very high thermal conductance. And in liquid lubricants, friction is very speed dependent. But in case of solid lubricants, it's really independent of the speed. And solid lubricants are often very sensitive to moisture. And liquid lubricants are very insensitive to air or vacuum. And life is determined by the lubricant wear, and life is determined by the lubricant degradation in case of liquid lubricants. So can you please change the next slide? Yeah. So main application of solid lubricants is in space industry because of the temperature range that it can sustain compared to liquid lubricants, and also of the friction. In solar arrays, in antenna pointing, and Lura Mercury Mars missions, many solid lubricants has been used. Mainly MOS2 is a normal form of solid lubricant that is used in space. So can you please change this next slide? Yeah, so this is a list of solid lubricants and their friction coefficient, based on which you can choose different kinds of solid lubricants for various applications. And there are different forms of solid lubricants like lamellar solids, soft metals, mixed oxides, sulfates, carbon-based solids. So that is the one I was talking about, is carbon-based solids, is DLC. DLC is called diamond-like carbon coating. It is a form of coating that is normally used widely as solid lubricant in the space industry. And organic materials, polymers, PTFE, which is like Teflon, which is a very good example because it has a very low friction compared to many of the others. Also, DLC has a very good friction, very low friction. And other metals like molybdenum disulfide composites are also used, and also thin film composites like normally nickel and chromium composites are very much used in this industry. So can you change the next slide? So types of solid lubricant, as I said, MOS2, PTFE, and DLC are very good examples. Because why? MOS2 is a very well-known solid lubricant because it has distinct layers. It has a layer kind of thing which shear easily, like by layer, which is very good for many applications. And there is a drawback because it can happen that then oxidation can take place and it can change its form from molybdenum to molybdenum oxide, and sometimes under ambient environment the friction and wear increases. So this is a problem in MOS2. In PTFE, it's very well known that Teflon is very famous even in the cooking industry for low friction coefficient for cooking and for many other applications. And even in the food industry, many parts of the food industry are coated with PTFE to improve the lubrication properties. And my PhD thesis was focusing on the same. My PhD thesis was mainly focusing on studying the difference between PTFE coating and other coatings when it comes to non-stick properties. And PTFE is always a winner because of its very low friction coefficient. And it is a very soft material. Sometimes it can wear easily. It has a very low friction, but it doesn't have a very good wear. So normally what people does is that they will always have a ceramic layer and then they coat PTFE on it so it can have a very good wear resistance. And diamond-like carbon coating, it is very famous because of its very, very low friction, like 0.003 sometimes. And it is a mixture of sp2 and sp3 atoms, and it can have many other forms of DLC based on the sp2 and sp3 atom structure. And it can exist as soft and hard coatings, and it is a very low and stable friction. It has a very stable friction even under ambient environment. I mean, unlike MOS2 coating. So can you please see the next slide? So biotribology. So what is biotribology? So biotribology, as the name sounds, application of tribology in biology field. I mean, when it comes to biological tissues or like forming cartilages, blood vessels, and ligaments, whatever to do with tribology in biology is called biotribology. It plays a very important role in medical devices, and especially in USA, they do a lot of research on biotribology because they are inventing always new forms of hip structures, as you see in the picture. Dental repairs, because dental repairs is a very good form of studying biotribology because many people have this problem, right? The dental repair problem. Many people want replacement. And what will happen when we replace these kind of teeth? It will be lasting for 10 years or it will be lasting for 2 years. So this is very important to know, for the lifetime of these kind of dental repairs. And where dental tribology is a very, very big field. People are publishing lots and lots of paper in dental tribology. And tribology of skin, lubricants and touch. This is very famous when it comes to companies like Unilever, because they do lots and lots of creams and they do a lot of tribological research. In Bangalore, they have a research center and they do also this kind of research in tribology of skin and lubricants for their creams on face, because to see how the cream will be applied when you apply, is it too soft or is it too liquid or too greasy? So it can change the feeling of the lubricant on the surface. This is very clear. And orthopedic implants, many people need orthopedic implants right now. So it's very important to know what is happening with tribology in such kind of implants. And in USA, this is a very big field because many people complain that they have problems after their implant. So this is very clear that they have to know what is happening in the orthopedic implants once it is in the body. Why is it so important in biotribology? Because our body is a very complex structure. Because we have blood, we have nerves, we have so many things. We have, whenever there is a stress, the temperature can increase in the body. So for all these conditions, this kind of material should survive. So this is very clear for many hospitals and many healthcare centers that these kind of materials should survive for a long time. That's why many kind of research are happening in these kind of field in USA and in Europe, mainly in US. And spinal disc replacements, which is also happening when it comes to a kind of any accident or something. People need these kind of surgeries, and this in spinal disc, they shouldn't wear out in time. This is also very clear. So this is why biotribology is a big field and is a very important field too. So can you please next slide? Yeah, thank you so much for the time. And it's a very, very big pleasure to talk to the Indian community after a long time. And so it's ready for questions. So you can please ask me questions. If I know, I can really answer. Thanks.
Thank you, ma'am, for your inspiring lecture on coatings tribology for protective applications.
Thank
Nearly
you.
600, thank you, ma'am. Nearly 600 participants are online for this lecture
Okay.
and have been enlightened with the information. Madam,
Okay. Sorry,
some
I
of our,
didn't
yes,
get the
ma'am.
last. I didn't hear you.
Nearly 600 participants are online for this lecture, ma'am, and have been enlightened with the information. Madam,
Okay.
some of our participants have few questions and I would
Yeah.
request you to address them.
Yeah, sure.
Meanwhile, we'll have a poll question.
Okay.
Dr. Sridhar will launch the poll question for participants.
Okay. Thanks. Thanks, ma'am.
Okay, ma'am. Please be for online for a few minutes, ma'am. The poll question was,
Yeah.
conducting virtual labs online is very challenging. This is general question, not related to the content that was delivered. Within 12 seconds, 90% of the participants have submitted the poll.
Yeah, it's difficult. I know.
Still around 18 seconds time is there.
Yeah, sure.
We will wait for 2 minutes. 87% of the participants agreed that it is difficult to conduct virtual labs online. Last 55 seconds. Only 17% has to vote still. Last 30 seconds. 84% voted. Last 10 seconds. Yes, I'm going to end the poll.
Yeah.
Let me share the result, ma'am. As it is visible for everyone, 80% of the participants agreed that conducting virtual labs online is very challenging. Only 14% disagree with the given question. Thank you for the poll question, participants. I'm just unmuting the participants who raised their hands. M. Sivasurya. M. Sivasurya.
Yeah,
I have
hello.
unmuted you. Yeah, you are audible, sir. You can ask your question.
Yeah, good evening, madam.
Good evening, sir.
It was a very informative session, like basic tribology and regarding surface coatings, solid lubricants, as well as in biotribology.
Yeah, thanks.
Yeah, I would like to ask one question, madam. That is, in many literature review, I have seen the formation of tribo layer is one of the main reasons for reduction of wear and coefficient of friction in dry sliding. Just I want to know what are the major factors for the formation of tribo layer.
So as I said in the presentation, whenever we start researching on a tribofilm, I mean, we also say tribofilm, tribo layer or tribofilm. And in that case, we always have to know what kind of pressure we are applying on it. So what is the contact pressure involved in that application? And what kind of lubricant flow is it happening? Is it full lubricant or is it a...
If it's a dry sliding, madam?
Oh, it's a dry sliding. Okay. In the
Yeah.
dry sliding case, it's mostly on contact pressure and on the temperature conditions. That is what we learned from our experiments, sir.
Okay. Does the material also will have an influence, madam, on the formation of tribofilm, contacting surface materials?
This is clear. This is not even an external factor. This is kind of, for example, when you use a stainless steel or and stainless steel to stainless steel, this is different. And when you use a stainless steel to a coating, this is also different because the coating can have an improved property on the wear of the steel. And also sometimes when you coat both the steel, both the specimens, then there is also a difference in the wear. Because this is what we were doing in our tribological study, to coat the steel with the manganese phosphate coating to see how much the property of wear has been improved on the stainless steel with these kind of coatings.
Okay, madam. Thank you.
Thank you.
Suresh Sripada, we have unmuted you, sir. Kindly unmute yourself and ask the question.
Hello, madam.
Yeah, hello,
sir.
Thank you, madam, for excellent presentation.
Thanks, sir.
Yes, I have a question on materials tribology. If the material is prepared in the nano size, how the nano influence on the tribological properties?
Okay, so nanotribology, that is not my specific field because I was working always on basically on 5 micrometer thick coatings. And when it comes to nanotribology, there are many literatures going on in nanotribology field also. But basically, why nanotribology means whenever there is the particle in nano form, as you know, the properties will increase dramatically when it is compared to other forms like micro level. So maybe this kind of properties will influence the tribological properties. One such research I know is that inclusion of nanoparticles in the lubricants to improve the lubrication properties of the lubricant for automobile application. So one such project I worked on directly, not directly. And in that case, they are trying to use nanoparticles to see how it can improve the fluid properties when it comes to additives. So there is a role of nano, this word nano in tribology, but I am not directly involved in that research, sir. So I cannot answer it directly.
Okay, thank you.
Thank you.
Dr. R.S. Chandok, you can unmute yourself and ask the question. Dr. R.S. Chandok. Satyasagar, you can unmute yourself and ask the question. Bhaskar Rao. Bhaskar Rao. I think he's not online. Dr.
Hello.
A. Nagaraj.
Hello.
Yes, sir.
Hello.
Dr. A. Nagaraj. You are audible, sir.
Yes, madam. Hello, madam.
Yeah, good afternoon, sir.
Yeah, good evening, madam.
Good evening, sir.
Madam, your lecture is very informative and significant, and it is influenced particularly for the researchers.
Okay, so thanks.
Yeah, madam, I have one question, one doubt, madam. You
Yes,
have
sir.
shown very advantages of tribologies.
Yeah.
And I have a doubt regarding, is there any disadvantages associated with tribology, madam?
What are the disadvantages associated with tribology? Maybe I can say one disadvantage because we say that we shouldn't use lubricant to improve the environment. But in tribology research, we do use a lot of lubricants for testing, which is a kind of bad for the environment. This is, I feel, disadvantage from the tribology. In other forms, I can't see any disadvantages because as a tribologist, I see only advantages.
Thank you, ma'am.
Thank you, sir.
Thank you.
Uma Maheshwar Singh.
Hello, madam. Your lecture is enlighten us on the topic of tribology, madam.
Thank
Let
you,
us.
sir.
I would like to know the scope of employability and scope of research area. Research area I have covered, but in India, like our country, what is the scope of employability on this tribology?
Okay, as a scientist who was in that place, so I can really answer for this question. When I finished my PhD in surface and coatings tribology and I went back to India, really I couldn't find any job. Actually, they said I'm overqualified for many jobs in India. And many of the laboratories like NCL, NPL, ISRO, they really don't care about PhDs. So this is the real status of what I felt when I came back from Denmark to India. But luckily, I found a company called making tribometers in Bangalore, which was very close to my home. And I was working there as an applied and research scientist. But when you see the prospects of getting job in tribology field, I feel that it is really limited, not only in India, it is everywhere. Even in Austria, I was working in a center which is famous for tribology. I'm sorry. Which is famous for tribology, and I couldn't find any other job in any other institute because there is no such tribology research happening in any other institute. So it was so difficult for me also to find a job in Austria, you know, after working in this field for more than 8 years. This is, I can say it's quite difficult field to find the job, that is for sure. But still, I see there are many universities coming with the tribological, with sorry, my kid, tribological research, they are starting new courses in masters, especially focusing on tribology in North India. I think I saw a course, and this is kind of coming up, but it needs a lot of time. I think it needs lots and lot of time to really see what is tribology role in India.
Due to lack of time, ma'am, this would be the last question.
Yeah, thank
Dr.
you.
K. Balachandra Kumar. Sir, unmute yourself and ask the question. I think sir is also not online. As we are running off time,
okay,
participants can mail their questions to the official mail ID,
okay,
and we will get back to you.
Okay, ma'am.
Ma'am, once again, I thank you for sparing your valuable time for us. I also thank all the participants for their active involvement.
Thank you, ma'am.
Thank you, ma'am. The
Thanks a lot for
feedback
the opportunity. Thank you.
The feedback form of today's session will be posted in the chat box and also in the Telegram group.
Sure.
Participants are requested to send the feedback form by today itself.
Thank you. Thank you, ma'am.
Okay, ma'am. Thank you. Thank you very much. Thank you all. Kindly log in tomorrow at the same time at 4:50 p.m. Goodbye from Team GRIET.
Hello.